Okay, so let us discuss some more problems based upon oscillations. So let's see this problem. The phase difference between the instantaneous velocity and acceleration of a particle executing simple harmonic motion is at pi, 0.707 pi, 0, 0.5 pi. So the phase difference between velocity and acceleration. We saw similar kind of question yesterday, right? So what's the answer? Option D, 0.5 pi. Right. Okay. Phase difference between velocity and acceleration is pi by 2. Let's see this next question. A particle executing simple harmonic motion of amplitude 5 cm has maximum speed of 31.4 centimeters per second. The frequency of oscillations is. So this is very simple question, right? This is one of the simplest question. Okay, maximum speed is given. V max, it's equal to A times omega. Okay, and V max is 31.4 centimeters per second. A is equal to 5 centimeters. So from this we can find out omega, right? And omega can be written as 2 pi f because we want frequency. Okay, so if we divide 31.4 by pi, we'll get 10, right? So then, so 10 is equal to 10f. That means f is equal to 1 hertz. Next question. Which one of the following statements is true for the speed v and the acceleration a of a particle executing simple harmonic motion? Option A, when v is maximum, a is maximum. Option B, value of sorry value of a is 0, whatever may be the value of v. When v is 0, I'm sorry, when v is maximum, a is maximum. That's first option. Value of a is 0, whatever may be the value of v. Then when v is 0, a is 0. When v is maximum, a is 0. Tell me which one is correct? See, there is v maximum at the mean position, right? V is maximum at mean position. And what is the value of a there? So acceleration is equal to 0 there, right? Yes, no? Okay, so it's option D. Okay, this was very simple. Next question. If a simple harmonic oscillator has got displacement of 0.02 meters and acceleration equal to 2 meters per second square at any time, the angular frequency of the oscillator is equal to. Again, this is very simple question. Displacement is given, it's 0.02 and acceleration is 2. So we know the relation between displacement and acceleration is what? A is equal to, so if we just care about the magnitude, then A is equal to omega square x, right? So we want angular frequency only, that means we want omega only. So omega square is A upon x, that is 2 divided by 0.02, that's 100. So omega is equal to 10 radians per second. Option A. A body is executing simple harmonic motion. When the displacement from mean position is 4 centimeter and 5 centimeter, the corresponding velocities of the body is 10 centimeters per second and 8 centimeters per second. Then the time period of the body is, okay, So we had solved similar kind of problem yesterday, okay, but there this thing was not given. I mean the values were not given. So v at v1 and v2 at positions x1 and x2, the speeds are v1 and v2. This thing was given, right? So here we can use this formula. V is equal to omega square root of a square minus, we can use this formula, V equals to omega square root of a square minus x square. So when x is 4, V is 10. So from that we get one equation, 10 equals to omega square root of a square minus, okay, 4 square. And then using the other information, when x is 5, V is 8, right? So 8 is equal to omega square root of a square minus 5 square. We get these two equations. Okay. So we can divide these two, cancel out omega, find out a, then substitute a to find out omega. Okay. So let's do that. So dividing, this thing gets cancelled. So we get 10 by 8 or 5 by 4, and squaring that we get 25 divided by 16 equals to a square minus 4 square is 16 upon a square minus. So from this we can find out a, right? So 25a square minus, so if I multiply this with this, it's 25a square minus 6 to 5 equals to 16a square minus what, 16 square, or from this we get, if we take 16a square on left hand side, okay, and 6 to 5 on right hand side, so it is 25a square minus 16a square is 9a square. So 9a square equals to 6 to 5 minus how much is 16 square, 256, right? 369. This is 9a square. So from that we get a square. So it will be 41, right? Okay. And we'll substitute a square. Right. So we'll substitute a square in this equation, okay, or this equation. So what do we get? A square is 41. 41 minus this 4 square is 16. Okay, so 10 is equal to omega multiplied by square root of a square minus 16, right? So a square is 41 minus 16 is how much? So it is 25. Okay, so we get 10 equals to omega times square root of 25, that is 5. Okay, so 5 omega equals to 10, that means omega equals to what? 2. Okay, so we got omega equals to 2, right? So 2 pi upon t is equal to 2, that means 2 pi upon t. So I will write it here. 2 pi divided by t is equal to 2, that means t is equal to, t equals to 2 pi divided by 2. Okay, so option C is the answer, right? The displacement of a particle executing simple harmonic motion is given by y equals to a naught plus a sine omega t plus b cos omega t. Then the amplitude of its oscillation is given by. So this is simple. Tell me. I is equal to a naught plus a sine omega t plus b cos omega t. So here we have two SHMs. right? And yesterday we learned how to add two SHMs. Okay, option C, right? Okay, so amplitude is given by R is equal to A1 square root of A1 square plus A2 square plus 2 times A1 A2 multiplied by cos of the phase difference between the two. Okay, so that is square root of A square plus B square plus 2 times A1 A2, that is A multiplied by B multiplied by cos of phase difference between these two. Phase difference between these two is pi by 2, right? It's pi by 2 and cos of pi by 2 is 0. Okay, so phase difference between sine and cos is pi by 2. Okay, so then this thing is 0, so answer is square root of A square plus B square, option C. All right, let us see next question. Out of the following functions representing motion of particle, which represents SHM? Tell me. First is SHM, yes or no? It is, right? This combination of two SHMs having same frequency. So it's an SHM. Second one, is it an SHM? Let's talk about second one. Y is equal to sine cube of omega t. Now we have this formula, sine cube of theta. So sine cube theta equals to 3 sine theta minus sine 3 theta upon 4. Okay, so here we have theta equals to omega t. So if we write sine cube of omega t, we'll get what? 3 sine of omega t minus sine 3 of omega t with this factor. Okay, so now here frequencies of this one and this one, they are different. Frequencies are not same, right? So frequency of the second term is 3 times as much than the first term. Okay, so this will be some periodic function. Okay, so let's suppose time period for first one. Okay, first function is suppose t. The time period of second function. Okay, second function will be what? T by 3 because frequency is thrice. Okay, but see, when this function, okay, sine omega t, it completes one oscillation, this one will complete 3 oscillations. This will be still periodic, but it's not SHM because frequencies are different. Okay, then this one, it's SHM. This is clear. Okay, it has got frequency of 3 omega. Okay, this is SHM. This is not SHM. What's the answer? First one is SHM. Fourth one, sorry, not fourth one. Third one is SHM. So option C is the answer. Right. Option C is the answer. Two SHMs with same amplitude and time period when acting together in perpendicular directions with a phase difference of pi by 2 give rise to straight motion, elliptical motion, circular motion, none of these. Option C, circular motion. Okay, let's start. So option C, circular motion. Can you tell me how? If we think of circular motion of an object, right? If we think of circular motion of this object, and we had discussed this, that if we resolve its position vector, along two components. Okay, I'm sorry. This x, this is y. Okay, so we had discussed this, that x is equal to what? This angle is suppose theta, that's omega t. So x is equal to r cos of omega t, and y is equal to r sine omega t. So it's like this. Okay, x and y, these are two SHMs, right? They are acting perpendiculars to each other. And how much is phase difference between them? So we can see phase difference is pi by 2. Okay, so these two combined SHMs, they give rise to what? They give rise to circular motion. We can think of it in this way also. If we square this and add, okay, if we square this and this, what will we get? X square equals to r square cos square omega t, and y square equals to r square sine square omega t. If we add them, so x square plus y square is equal to, we can take r square common, cos square omega t plus sine square omega t. Okay, so that's one. So x square plus y square is equal to r square. Okay, so this is a circle, right? The composition of two simple harmonic motions of equal periods at right angles to each other and with a phase difference of pi results in the displacement of particle along a circle, figure of 8, like this. Okay, straight line or ellipse. Now, can you tell me? So, composition of two simple harmonic motions of equal periods. That means frequency is same. Okay, uh, they are acting right angles to each other and with phase difference of pi and now, not pi by 2. I'm sorry. So we can write x is equal to a sine of omega t, y is equal to what? A multiplied by sine of omega t plus pi. Okay. So it is sine omega t cos pi plus cos omega t sine pi. Right. And sine pi is 0, cos pi equals to -1. That means this is minus a sine omega t. Okay, so now if you, okay, so see here, y is equal to minus a sine omega t, x is equal to a sine omega t. So what will be relation between them? You can say y is equal to minus of x, and what is this thing? It's a straight line, right? Equation of straight line is y equals to mx plus c. Okay, so consider c equals to 0 and m is -1. Okay, so this is equation of straight line. So what's the answer? Option C, straight line. Got it? Yes, no?